Now recording. So this is our agenda today. Okay. So I'm gonna first basically do the two very important things that we did on Tuesday. Okay. So if you were not here or if you're still going to do that, and this is your chance to do it. So feel free to log in to those computers if you don't have a computer. Okay. So I'm going to show you one more time how to do those two things. It's not that the difficult task of probably take 5 10 minutes. Okay. So and then we're gonna start, and then we should be able to finish this by this lecture. There's mostly conceptual stuff, right? So yeah, and then yeah. All right. So before we begin, any questions? Yes. The reading due due today actually. So I say for the first week, I mean one thing, right? So we don't have penalties deadlines in this class. So since we started Tuesday, right? I couldn't ask you to do things on Monday, right? Going forward, the reading will be due Monday. So you should be getting into chapter two, and I highly recommend finish the reading. I mean, that doesn't mean like 100%, right? So you can finish by when you can finish the chapter like the participation wise chapter two by Wednesday. That would be great. Okay. So in the canvas I put actually okay recommended finishing day for cyber challenges is Wednesday night. So basically, then by Thursday, we kind of review it in the class. Okay? So you remember that the video we watched, right? We want to get the information, transfer information at home. That's the whole idea of the cyber. Okay? So you do it ahead of the time, and then we use them. We implement it in the classroom. So that's the kind of goal. Okay. So try your best to get the reading done by Monday next week for the chapter of that week or the module of that week. Okay. All right. So so that's my recommendation. Yeah. So definitely the challenges by Wednesday. Okay? So because that is one of the reasons. Like if you go to the module view over here, so you can see that there's in between deadlines, right? So those are all suggested deadlines, and you can see the module deadline is over here, 24th, and you'll see that the assignment and the module reflection they both due on 24th. Okay, so that's the end, right? So and in between deadline, and again these are not enforced. So there's no penalty. So one, that's a good question. One other reason is, unfortunately, when we put a deadline, Canvas go ahead and if student miss the deadline, Canvas go ahead and put a zero. So automatically, okay? So just especially for quizzes, Canvas does that. So that doesn't mean that you got a zero and it's final. No. Once you submit it and we see that, we manually erase that. Okay, so that may take a couple of days or a week. Okay, so and that zero gonna hit you a grade book, right? So your grade gonna get hit temporarily, I would say. Okay? So, but it's a temporary thing, and then once the grading starts, hopefully next week, we'll manually change those based on the submission. Okay? So don't worry too much about it. And then again, this we just started with so and then PAs, none of them actually hired yet from the department, so they're working on the payrolls and stuff. So hopefully starting from next week we can get going, okay, in the grading. But I'll try to grade during the weekend file to assignment. This one, okay, and the discussion, okay, during the week. So for some of you, it's really sort of I don't know how it kind of does. Probably due to the missing the deadline, the government is going to put a zero and grade. Okay, so yeah, so take a note on that, but that will be fine after start grading. Okay. Any other questions? That's a good question actually. All right. So for those who are here coming today, get your computer or sit in front of, log into cameras, okay? And then we should have CAs coming in starting 9, okay? And then they will also help you as well, okay? All right. So, all right. So we did this on day one, right? So this is the one. So let's do uh, right. So let's do these two things just quickly. So I'm gonna open that first one, the discussion, right? So this is the one, and at the same time, if you have a question, guys, feel free to ask. I'm gonna ask those new today to log in to access this one. Okay? So I'm gonna um, raise your hand if you are new today. You didn't come last Tuesday. All right. So and you can ask from your neighbors as well. They know the process. You have decided. Okay, so you can actually buy today as well. All right. So, all right. So, so this is the pattern, right? So I solved the problem that we solved the previous class. Okay, so let's skip it. I know you guys did it, but this will not take that long. Okay. So, how many of you got this one done fully correctly? Rest of you did it, right? Okay. So did you compare with others on the section? Yeah. If, yeah, I think if it's looks similar to what I submitted, that's it. You'll get 10 points. Okay. So, the credentials are on the top corner. And guys, one other thing, right? So if you so let me go to I'm gonna go to student view, and you should be able to see what others submit. Okay, okay. So and then you can take a look. But, please do not copy paste from others. Okay, that's not right. Okay. So what I suggest you to know is take a look at what others are doing, try to understand that, and then write it in your own terms. That's I highly recommend. Okay. Right? So that's why it's a forum, right? Forum. The coding forum for the class. So so we everyone submit their solution. So so it's the graded discussion. Um, so it's a little bit too easy. But you can follow me right now. Okay? All right. So it's a repeat, unfortunately for many of you guys, but I'm gonna quickly be done with this. So so there's a problem statement, and then basically if you go to step two, run example the Python code over here, right? So um, right. Um, what's your name? Cynthia. You can take a look over here. Okay. So I'm gonna click on this link, right? And it takes me to this code. Okay. And I'm going to run it. Okay. So I'm on go. So it's download the file. You can do now, right? You can follow me, right? So click the link and then go to that code. All right. So download it. It's the third button down below, and then you can run it. Okay. So it's the first button down below. It draws a fish, right? Okay. So don't worry about the code. We're gonna actually be able to do the same thing in this class and by the thing. So we'll do that actually at that time. So and now you can save the code in the second button, but do not override. Just use a different version, right? So new version or new file, either one is fine. So I'm gonna use new revision. Okay. So it's gonna basically update the link above, right? So the link of the web page. Okay. So and then we're gonna basically copy that code. Okay. So Control A or Command A inside the black box. You can also select mouse as well, and then Control C or Command C, and you're gonna paste it in now the reply box. So you're gonna go and click on reply in the discussion. All right, down below. Um, well, you have to scroll up. Yeah, you're there. Okay. So and then paste it. All right. It should be just text. Okay. So not an image or anything, just code. Okay. All right. So and then select all in the discussion reply, and then you change the format into inside the reply in the format into should be on the top. All right, control inside. So select all the text inside and click on this drop down menu, paragraph drop down menu, and select pre-formatted. Okay. So that's the formatting. So we are formatting the our text as code, and at the end, so you can go to the end of your reply. And now we're gonna go to click on this icon over here. All right. So that's the HTML mode. Okay. So just our code in HTML, right? So now we're gonna basically read the instruction back, go scroll up and copy this template code. Okay. And then basically we're gonna go down. So here's the template code down below. It's right here. All right. So we're gonna paste that, and then only we have to do is this update with this link. So you're gonna go to the our code and get this link. So this is the link on the top. All right. So you click that link and then paste replace that link in here. Okay. So that's it. So this part, we're gonna replace it this. All right. So make sure do it in HTML mode. Otherwise, you will see this gibberish in your submission. So, so we're gonna replace that. Um, and that's it. Then we can submit our post. Okay. So I'm gonna replace this template code link with the one that I have. All right. So I think I may have made a mistake. Let's see. So if I toggle the button, and I should see the embedded page. Yeah. Okay. All right. So this is so I'm gonna submit this, and you will see this as your instruction in there. Okay. All right. So that's the first part. Okay. Yeah, you can copy that. That's an example. Yeah, copy that. Yeah, it's this and together. Yeah. Now we place this for that. What happened to your code? Okay, you can edit later. That's fine. Just you can do it right now. And then you can edit. So click on the same button down because it's gonna show you this. So go down. Yeah, it's there, right? So you can now return. So later on, if you made a mistake, you can mistake. Okay, so that's that part. And the other one is we're gonna quickly go over. It's basically that assignment, right? So we downloaded this code, right? So we're gonna go to that assignment, basically this one. Um, how to yeah, this one, how to submit an assignment, right? So click on that. Can you open this assignment? This one. It's in module one. Okay. And new attempt. Click on new attempt or submit. The red button on top, and you select the file. That's it. Okay, this is how you actually submit a programming file to an assignment. Okay, so we are basically practicing that. And that's it. Okay, and I submit. Okay. All right. So, all right, guys. So let's move forward. So I'm going to start with this one, but before that, let's answer some of these questions. So I hope you guys read this because it's again all conceptual stuff. Okay? So you guys can just read it. So what I will do is basically I'll pick a couple of questions and do it together with you. Okay, so that's what I'm going to do. Okay, so um, all right, so let's answer question number 3. Oh, what is the answer? What is going on? Don't lose your time. Okay. So what's the answer to question number three? False. Okay. All right. So it's depend based on this graph, right? So it's less than that much. Okay. Then it's still going, right? Okay. All right. So we're gonna go to the next section and answer another question. Okay. All right. So let's go to the bottom and see if we have a question. Okay. Let's do this one, guys. Okay. So you're gonna so I'm gonna point to um from the top, and you guys going to tell me which one should I drag and drop. Okay. The first one, computer bulb. Okay. All right. All right. So that's the first incident of. So the second one, the machine used to compile statistics. Okay. Punch card. Who first used that? Was it a programmer or a scientist? No, I mean, who invented the punch card thing? Sorry. Yeah, for the loom, right? The point machine, right? The fourth loom, he used punch card to pick the pattern. Uh, actually, it's starting from actually the loom, like, the weaving machine in cloth designs. Okay. All right. So third one, a program uses third one. Compiler. Okay. A program used to convert mathematical instructions written in English words into machine code. Compiler. Oh, is it? Let's see. All right. Uh, next one. The cryptographic machine used to decipher messages accepted Enigma. The yeah. Oops. This should be out of this one. All right. All right. Next one. Computing Tabulating Recording Company (CTR) was renamed in 1924. And the last one is COBOL, I think, right? Yeah. So it's kind of a dead language right now. All right. So I'm gonna go to the next one. All right. So again, we're gonna pick this last question. Let's say the number three. The number of embedded computers are greater than the number of desktop and laptop computers. Okay. So there are two answers. All right. So let's try false. All right. It's true actually. Okay. So it's in this right here in the text. So basically, the answer is here. It's it's what do you call that law? That's a name for it. Yes, Moore's law, right? So basically, the number of transistors in a chip is doubling each decade. So we call it exponential growth. Okay. So and then it's actually there's a graph for that, and we'll encounter that graph later. But the law is called Morse law. Or Morse law. Okay. So all right. So let's right. So we're gonna go to this one. Any questions before we get into this one? All right. All right. So this we're gonna spend a little bit time on this topic. So programming in general. Okay. So so before we getting into actual um, code programming or software programming, let's talk about real world problem solving. Okay. So let's take like let's philosophically talk about this topic, right? You know that like, all of us solve problems every time, right? Like every second we will be living, right? Solve a problem, right? Take an input and do something and do something after that, right? And it's output, right? So so and then we didn't pay attention to that much, right? So let's good time to philosophically think about this actual physical problem solving process. Okay. So if we take a problem in real world, and we know that there's always an input, right? So let's say I want to go to uh, point A to B, right? So in the say in the city. Okay. All right, imagine that. And imagine GPS or your mapping app is not there. Okay. But what do we used to do? Yeah, read a map. Yeah, we use a map, right? So basically, so it goes like 80s and then until late 90s. So you use the map, right? So at that time, the printing company who printed map books, right? They were fighting actually. So until the GPS came and they went back up pretty much, right? So so we basically we want to go from A to B. So imagine city A or city B or address A to address B. Okay. So what do we have when when we want to go there like this? What one of the things we have? The inputs. What are the inputs we have? Yes, but more specifically, yes. Yeah, so basically we know that where we are right now, usually, right? We can also find it in the map as well. So the starting location, right? Or starting address. And we also know that where we want to go as well, right? So, so we all both have input, right? So address basically A and B location basically. So it can be just casual location in the map where you are, can be an address as well. So and then so those are the input, right? So and then basically we take a look at the map and figure out how to get there, right? So the road map, and we have to make some decisions. So for example, the closest there is a closest closest path or other things that you have to follow. Sometimes it's a one way, you cannot take that road, right? Imagine you are driving actually, not walking, right? So there are many things to look, right? And then sometimes there are tolls. If you want to avoid that, you have to take that decision. So that's the process over here in the middle, right? Right? So that's basically the solution. How to go from A to B. So you take a look at the map and you figure that out. Okay? So that's basically the process or the solution. Okay? Can you guys read this? Is it this one blocking? No? But how about for you? little bit off, right? That's unfortunately, so basically what we have is we have the the input, right? We need to go from A to B, right? So input A and B information, and this is the process, basically the solution. And basically once we go there, right? So that will be the location, but what's the output or outcome? Arrival. Yeah, arrival. Successful arrival is the output. So it's a kind of a yes no question. If it is no, you go back to basics and reevaluate, right? So that's basically pretty much the overview of the real world problem solving process. So we have an input, right? Bunch of could be one, could be a whole bunch of inputs, okay? And then we solve the problem, it's a process, and then we have the outcome. If you don't get the desired output, you go back to the beginning and reevaluate our process solution because our solution is now wrong. Okay? All right. Any questions? All right. So pretty much, if you think of real world problem, you have these three things. You have input, you have a solution. So you come up with the solution usually, right? So you are a team, and then you have the output. Okay. So here the basically reaching point B is the output. Okay. All right. So and then, and then sometimes in reality, um, we have devices that solve problem, right? And all of this projects are solve a problem, right? Of you know transferring what I have in my screen to this screen, right? So microwave solve a problem of cooking, right? So if you take a car, right, that also solve a problem from driving a person, taking first the person from one point to the next, right? So take for example a car, right? So what are the inputs? Steering wheel, gas, gasoline, so pedal, right? You know what else? Engine. Yeah, yes. So basically, the person who operates the car has set of inputs, right? You can name many. Car has a lot of inputs, steering, braking, accelerating, and many things. That are a lot. You can name car with a lot, right? So, and what's the output basically? Well, basically, if it is meant to drive a person from one place to the other, then basically you do that successfully, right? That's the outcome, right? That's expectation, right? So here's my question. So what is so for the user of the car, right? We call it like informally we call it the client, right? Right. So basically, if you take if you go to a restaurant, right? Who are the clients? The customers, right? And who is the server? Waiters and others in the restaurant, right? So in software industry, we call that client server model actually. So server basically sells something like a task or service, right? And then usually the client requests it, right? So it's the same idea here in physical world too, right? So in terms of car, who is the client? Driver. Okay. So client has the input. Okay. All right. So who is the server then? The car. Okay. So what is the most important thing for the client, the driver? Being able to drive to the point, right? So that's the most important thing. So is it like and actually that is it. So if I have a car and it works and it can as long as it takes me to point A to B, I'm fine with it, right? I don't care how it does, right? So that's pretty much everywhere we see. Right? So we don't care how it works, we only care what it gives us, right? So usually this how it works is in the solution, and it's actually kind of blind to the client. Okay? So, so in terms of car, we don't care how the internal combustion works, how the engine system works, right? We only care whether it successfully drives us or not. Okay? So this way of thinking is called abstraction. Okay? So so it gives us a way to think like, okay, so there's a lot of information over here, right? A lot of obscure information that I don't need to know, right? So and then that's basically so it's good to black it out for the client, but if it's like for example, the engineer who makes the car needs to know that process, right? So um, depending on the person, that we basically having too much information out there, everyone to need, everyone to see them, it's actually not a good thing. Okay? And that's why we call this abstraction, and abstraction is a good thing, right? So another example, can anyone give me another example? First, take microwave for an example, right? So uh, we 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 use microwave for cooking, right? So we don't care how it does how the microwave comes and does the cooking, right? So what are the inputs for a microwave? Timer. All right. Yes. Food is the most important input. So you put inside, right, and then you cook. There are others, yeah, button pressers and turning. So all of those are inputs, right? What's the output? Yeah. It's either warm food or cooked food, right? All of those, right? Defrosted food, right? So that's the output. So we only worry whether it does that job or not, right? We don't worry about how it does that job, right? So that person is actually the engineer who designed that. So in this class, we are going to be the engineer who writes the code. So we need to know the process, how to do it. But for the user of our solution, they don't care. They only care about solution. And this model is actually everywhere in both physical and software world. And in software world, we solve problem in what we have in physical world, right? So there's a nice connection to it. Right? There's a one-to-one correspondence between solving problem in physical world and software. Okay? So so that's basically it. So we are just starting on that. Okay? And you can see that there are three parts of the computer program. Basic one is we have an input, and then we have a process, basically the solution we design, okay? And then we have the side out. And if it doesn't work, we go back and forth and re-evaluate our process. Okay? So that's the actually iterative process. All right. So we're gonna get more into that actually starting week 4, where we can actually write code in this class. Okay. All right. So let's quickly run um, this one. So this is a basic computer program. So we have an input x equals another input y equals to. Basically, we get the sum. Very basic one. Two inputs x and y. Okay. And then the process is, what's the process here? That's all the solution. Yeah, this one is the solution, right? And then C is the output. Okay. So this is a simple one, right? So this is the process x plus y. Okay. And then we have the C output. Okay. So that's the process, and then the output. Okay. And if you think philosophically of any problem we solve, we have input and then the solution or the process, and then depending on the nature of the input or the output, we may have a variety of things. Sometimes the output is just a yes or no, like in that map example, whether we arrived correct place or not. It's something like that, right? Yes or no answer. Okay. All right. So let's answer some of these questions, guys. This one, number three, 30. Okay. So you basically type it over here, right? Okay. All right. And I made sure, so Cybook always give an explanation for both incorrect and wrong. Take a moment to read it. So that's automatic feedback is really good from Cybook actually. Okay. All right. So and you can see that this is a this this program or recipe to solve this problem, how to make chocolate cookies. So that's the problem is how to make a chocolate cookies, right? And then the inputs are the ingredients, and then step one by one. So we call it recipe, okay? And then in programming world we call it the algorithm. Okay? If we just counting. All right. All right. So this problem solving thinking process is solving problem in coding or in programming. We call computation. And so this is just a difference between actual thinking and between this one, right? What we want to achieve, what we want to master is actually, mastering. And in this class, you will actually definitely by the end of this class, you will actually be a master of that. How to apply this skill. And I will actually learn few specific techniques and one counter technique to do that. Okay? So so there are we'll get into that in a little. So the the process we follow or the sequence of instruction we follow to solve a problem in computing is called okay? And for example, and it's actually valid for real world problems too, right? So if you take this one, and here is the algorithm, okay? So how to this right here is the algorithm on how to make okay? So these are the step by step process, right? So that's the algorithm. So I would have bullet this actually, not just bullet this, but these are actual number steps would have been better, right? So step one is this, two is this, like that. All right. So All right. So and then in this one, let's do this one together. So this one, we're gonna actually come into this one again. Many of the first classes we'll actually remember we draw this one, right? So we call it turtle Python turtle package, right? So we're gonna right. So this is actually related to that one. Okay. So basically, so if we imagine a turtle, it's almost nine, right? Let's take a break, guys. We're gonna watch a video on growth mindset, and I'm gonna come back to this one. So, and we have Bridget here, so one of the TA. Um, we'll introduce Bridget after the intro. Okay? Oh, that's fine. That's fine. I was familiar, right? Nice. You should talk about that in the lesson. Okay. Yeah. So, and then you have they are asking you to come back, right? Oh, nice. Okay. Nice. So, yeah, that's always good actually. So you don't have to. So they know about you and they kind of you just need to apply. That's it. Yeah. So what are what is your take? Okay. Okay. Oh, okay. Okay. Oh, okay. Oh, four courses? Three. Okay. So are you taking 199? You have a lot of you have a lot in the three, right? And if you are working with them and then so what do you have instruments I think? Okay. Oh, okay. So did they ask you to take it before summer? No, right? Did they ask you to take it? Oh, oh, okay. Oh, okay. So how was the like how did it go? Okay. Yeah. Mhm. Yeah, I mean that's always that's how it works, right? You will be asked to learn and then so for us actually like in 2023 we had to learn everything about the digital radars, so technology, so how the distance calculation works, how the reflection combination and sensors work, and how we had to learn all. Yeah, so it's challenging, so it takes time and so it's a good learning experience. That's what they expect to, it's the motivation to learn. No, I have one of my friends, he's a scientist there. And there are a lot of people there, right? Did you, did they take you to the tunnel? No. Oh, okay. From the city of Chicago, right? Oh, okay. Yeah, yeah, yeah. The tile is now they're not upgrading, right? So
They
the
don't do it over the summer.
oh, I thought they actually closed.
One of them, yeah,
Oh,
the
okay.
restaurant.
Oh, yeah. Because after century,
Mm-hmm.
they people didn't use them actually. That's one of the reasons. But also, I think Korea has the first nuclear reactor. Did you check that? No.
I didn't
Oh,
know about
the,
that.
the graphite one. It's now the same problem.
Hmm.
Yeah. The Indigo form, the one that Indigo formulae,
Hmm.
the first nuclear reactor.
Oh, they also had like an area for quantum computing.
Oh, okay.
It was a bit underwhelming. I didn't know much about quantum computing before, but after learning what it actually is, I was like, oh, it actually has very limited applications.
Yeah. Because I think we can add now, right?
We can add now.
I think that's it right now.
I see.
It's really hard to lock states, right? So, all right, guys. Okay, so let's wait for two.
Is Kevin a PA as well?
Yeah, yeah. He will come actually around time.
Okay.
Oh no, I think he has a class. He come at 10. And you remember Subodh, right?
So
He's a
PA as
PA
well.
now. All right, guys. So this is Bridget. She was my student fall 2024, right? Yeah. I would say she was the best in that class actually. And also, she just finished an internship at National Lab, right? So she applied to CCI program, right? So I was interested in that as well. We can ask how did that go and how we work, right? To apply to that one as well. But go ahead.
Hello, my name is Bridget. This is my second year doing computer science at CCSN. Um, I've done CS110B and 110CS class. So if you have any questions about those classes or C++ versus Java, I'm happy to help. And if you have any questions related to this class, obviously I'm happy to help. And yeah, I look forward to the semester.
Can we talk about
Oh
the
yeah,
internship?
I also I was an intern at Kermit Lab over the summer. It's one of the DOE laboratories. They have a program called CCI and they accept community college students. So it's a really great program.
All right. Thanks, Bridget. So if you have any question on those, ask how did she apply and all those. So that's he has a lot of information on that as well. So, but I'll share those information in Canvas as well, like how to find those and how to get my help to complete the application and stuff. All right. So we're gonna watch a video now, guys. Okay. So that is going to be this one. Okay. So this is and especially in computer science, okay? Right? In programming or for engineers or anyone who want to have a career, we need to have this thing called growth mindset. And particularly in programming, you need that because there's a you will solve a problem. from the first attempt. Right? You also ask experts of time, and it's really unlikely. Right? So we haven't posted this much, okay, so it's failed, now we go back and reevaluate, right? So that requires this mindset. If you give up on a couple of attempts of attempting, and that's not going to work, right? So especially in coding, we require that. And this is basically going to show you a few tips. Okay, so it takes just 6 minutes, and then let's take on that. Okay. Oops, I'm still a student. That's why. So I'm gonna publish this one, guys. Okay. So could you all refresh your canvas view? You have access to. You can watch it in a silent mode and then find the answer as it plays. Okay. So all right. So let's go to the preview. So this is where we stopped. Okay. So so before we getting into this one, so let's think about a turtle, right? Like full turtle on a whiteboard like this one. Um, not over there. But everyone can uh, do this, right? All right. So there's a turtle. Okay. So try to draw one. Okay. And then there's a tail, and then there's a pen attached to it. Okay. So this is say the whiteboard. There is the forward direction, and this is backward, and the other two directions. Okay. So there's a pen attached to it. Okay. All right. So what will happen as it moves? Yeah, so it's gonna draw a line, right? So so basically, if I ask it to move forward by 100 steps, right? So I'll get a line of 100 steps, right? So and I can also ask to okay turn left by 90 degrees, right? So it will turn, and I'm now sitting there and ready to move. If I ask again to move forward 100 steps, it will move again another 100 steps, right? And you can see that we can ask this circle to draw a simple square from this, right? So just ask it to move from here to here, and then turn 90 degrees, and then move here, and then turn again 90 degrees, turn left again, right? And then move here, and then turn left again, and come back to our just draw a square, right? So 100, 100, and 100, right? It's something like what they are telling you is that, giving you that. Okay? So when up means so turtle can lift the tail up and down, right? So if it's lift the tail up and then move, will not draw. It just simply move, right? So it's not touching the whiteboard, right? So um, so that so the process is over here given to you, right? So let's try to so what it's telling you is basically um, right. So let's say our problem is to draw a square. Okay. So we can let's try to use this um, these actions and then solve this problem. Okay. What's the problem? Drawing a square. And using this type of concept. Okay. And then bunch of actions are given to us. Pin up, pin down, forward, left, left, right? So all of those are here, and then you can But first, we need to write the algorithm, right? Right. So, um, what? So, can we write it down together? That algorithm, right? What should be the step one? Forward and down. And down, right? So, yes, because we don't know whether the table is lifting the table or not, right? Just need to make sure that, right? And down. So, forward by 100, right? So, I'm going to short hand base forward by 100. This could be 100 pixels, 100 steps, 100 meters, any unit, right? So, step 3, left by 90, right? So, left by 90. So, by, okay. So, step 4. Step 4. Everyone needs to chip in, guys. Okay? You will count, right? Forward by 100, right? So forward by 100. Step 5. So left again, right? Left by 90 degrees. And you can see that we can continue, right? So step, step 6 is forward by again 100, right? And again, left, right? So there are three left turns, I think. So this is left turn by 90, right? So what's the last step? Um, one more left. One more left we have now, right? One, two, oh yeah, yeah, one, two, three. Yeah, we need to go. We are doing square, right? So let's one more go forward. Okay. 100, right? So what is this actually? This is the solution, right? So solution to the problem, drawing a square using a circle, right? Using that circle. Okay. So basically, if you hand do it like imagine your hand is like your pen is the circle pen, right? So you pen up first and pen down now, right? So right? Pen down now, move forward by 100, left, right? Second one, right? This one, third one, then move forward again, and left, right? So this is step one. Sorry, step two, three, sorry, three, and then four, five, like five, and you come over here and it's actually step seven, right? Okay. So this is the square, it's like a rectangle. Okay. So and then we're gonna use this Python table, like the one that we drew the fish to draw simple, starting from simple shapes, and then we're gonna go complex like that. Okay. So during this class, so we're gonna start that starting with four. Okay. So all right. So this is the algorithm. Okay. The solution. Basically, it's a step, a bunch of steps or a recipe that you can follow one after the other to reach the um, output or the goal, right? So let's try it over here. Okay. So the first one, what should I do? Pen down. So you have to click it, right? Oh, oh, oh yeah. Okay. Well, let's. Oh, we have rearranged, right? Sorry about that. So I'm gonna clear that. Okay. So this one, we can simply run it, right? Oh, what's going on? No. Yeah, yeah, you're right. So let's clear. There should be a reset button. Okay. So let me put it and down, and you have to put it all the way to the top, right? Okay. So pin down, forward by 100, turn left. So this is gonna draw a rectangle, right? Sorry, I think the equilateral triangle. Same process, okay. So, and you can see that. All right. So pin down, move forward by 100. And this angle is 120 degrees. So turn that and then move forward again. Turn again 120 and move forward. So I think we can, they allow, we can actually use this to, yeah, let's try to use this to draw the square. Okay? So forward, so let's say 100, all right? So we have that, so we're gonna, um, do we have, yeah, so we have to do it over here, right? So 90 degrees, enter. So I'm gonna do this over here, okay? And then forward. So these steps are correct. So we're gonna remove that, right? So turn left. So you have it over here, right? Like that. So I'm gonna, yeah, I'm gonna remove that, and then because we are following the algorithm, right? So let's follow that algorithm. So we have now, okay. So step 1, 2, 3, 4, 5, right? So step 6 is going to be again move forward by 100, right? Right, and then step 6 again, I think. Turn left by 90, right? And then last steps, move forward by 100. Okay. All right. So, so this is the algorithm. So let's run it, and it should draw a square, right? So, um, so this is the, and then this, and you can see that there's no code over here. So this is the algorithm, right? So basically, a simple bunch of steps from top to bottom is written in plain English, right? Make it a habit to first do that every time you solve a problem in coding, okay? And that's actually the most challenging for many beginners as well. So it's really important that you learn how to design your solution before you start coding it out, okay? And also, industries are also now getting to, I think I talked about this last time also, right? Um, they are also now measuring the students of interviewees' ability to design a solution, right? Not coding, right? So it means you'll be asked to go in and write your design the solution and write your steps, the algorithm. That will be enough for them because coding is right now, they are also taking part of it, right? So they are more interested in designing part in the person. Okay. All right. So so that's that. So it's gonna go to this one, and this again why coding careers are important, and then those stuff. Okay. So there are a bunch of examples. And then, salaries. These are even way more than these values right now, especially in this area. This is I'd say the highest paying area for tech jobs, right? Silicon Valley. Okay. Probably these are averages, maybe in the United States. Okay. All right. So I'm gonna go to the bottom of this, and we can. Okay. So let's do this one together, guys. Um. Okay. So this one. Let's play this animation real quick. All right. So this is basically learning programming trends to aid in precise logical thought aspects of compressor. Okay? So pretty much you can think of designing the correct algorithm, okay, that solve the problem is part of compressor. Okay? So and then this actually shows you that okay, all right, all right. So this is the final end product, right? Okay. So right here at the end. Okay. All right. See, we can solve this. Okay. So you're gonna help me do this question, guys. Okay. All right. So I'm gonna this time I'm gonna back and drop. Which one should I drop this one? Please. Software developers. Computer support specialist. Computer support specialist. Oh, you're saying the first one? Yeah, first one. Okay. This one. Okay. The next one. Okay. Create. Design. Software. Program software. Yep. That one. Help write programs created by software developers. This one. Oops. I made a mistake. This one, right? All right. Number 4. Computer system knowledge. All right. Number 5. Information security analyst. The last one is web developers, right? Okay. All right. There are examples as well. Okay. Okay. So we move on to the last topic, I think. As we already talked about the similar stuff. Okay. So in this particular one, there's an example over here, and you can play the animation. So this one basically determines whether a number is a prime number or not. So input is a given number, have a way to check whether it's prime or not. So that's the solution, and then they basically you output the number whether it's a prime or not to the screen. Okay? And you can see that in designing a solution, these are the parts of comprehension thinking. So one is decomposition. So basically, you break down the problem into pieces, smaller problems. If, particularly if it's a complex problem, you require that. Okay, so that's called decomposition. And then pattern recognition. Basically, if you see a pattern that repeating, maybe repeating or something else, and you need to basically recognize that. Okay? So pattern recognition. And algorithm, basically, you have to come up with the sequence of instructions. You have to make sure that solves the problem, otherwise you have the wrong outcome, right? So basically, if you are responsible for getting the algorithm, you have to make sure that it's actually the correct algorithm. Abstraction, we don't talk more about it in future classes. Basically, you generalize the solution so that you can apply it to many scenarios, right? For example, if I invented the microwave just to cook, let's say, only pasta, what's the point, right? To be able to generalize that cooking process into many scenarios, like warming up, cooking, defrosting, and other foods, right? So that means your solution, single solution is applicable to many scenarios. That's called application. So basically, you are applying abstraction. So basically, you have an extension of your solution so that you can solve many related problems. Okay? So in software, this is really important because again, you want to be able to solve a lot of single problem, not just one particular problem. Okay, and it's the description also there. So let's do the number one, number three, guys. This one. Count the number of sums from the previous question. Okay. Multiply this number by 101. This number is the sum of integers between 1 and 100. What is that? Anyone else? All right, I'm gonna click on that. All right, so it's correct, right? So basically, expressing the process to get this sum, right? So that's actually the process, the algorithm. Okay. And then try all the others, and there are different choices as well. Okay. So the last one, so this is the last step in this book. Okay. So it's about collaboration. This is again the conceptual topic, guys. Okay, so you guys can read about it. So we gonna have I'll be including a project in the midterm on collaboration. Okay. So I'll talk about more on that later. So it's actually I think they mentioned GitHub somewhere here. Version control, okay, such as GitHub, and then you'll get to learn some basics of GitHub to manage manage your program. Right? Okay. So this project is about that. So and I'll teach you how to do that, and then you basically give me a simple project from your own on a couple of steps that you use GitHub to store a program that you have. Okay. All right. Um, so that's about it, guys. Okay. So so this concludes chapter one. Okay. So again, it's a really conceptual topic, the chapter one, and it would not take long to translate. Okay. Chapter two, on the other hand, will be longer. Okay. So starting this week and please try to finish it the seventh by next week. Okay. So I recommend finishing it on Monday, so that Monday night, so that we are kind of going over the second time in the class. So all right. So that brings us to our the other problem, right? So our other topic, which is this one. All right. So we're gonna write an algorithm to solve this problem. So how to make this smooth. So again, remember, Sarah. So find your partner on Tuesday. Okay. So get together and share ideas and write this one. So it's we're gonna follow the same procedure this time. Okay. So similar set of instructions there. Okay. So let me publish it. Okay. So it's published now. Okay. So basically going to design an algorithm to solve how to make the smooth problem. So get together, guys. Come on. Pair programming. Okay. And this one is not that. you know, complex problem, but again, you're not coding it yet, right? Because until they code, they're not going to code anything, right? So it's going to be something yeah, yeah. Go ahead. It's published, guys, okay? So it's in Canvas now. So you want us to start in the Python sandbox and write. Yeah, so but still not going to be code, like like this one. Write your technical functions. Yeah, the reason is I still want you guys to get familiar with that tool because you're gonna keep using this one, so it's the second time you're using that. But this time it will be a little bit boring because there's no diagram for you. Right? Yeah. But you will soon, like starting in week three, you're gonna draw diagrams using the things that we learned in the past. Yeah, using that. Use that. And that was actually the Tuesday class. It was that type of practice that right. We used that. All right, so time. I'm gonna take the attendance, guys. Um, well, I put everything in the blender there. Blended. Um, so I guess it would just be like, preparing whatever way retrieving. Yes. So you know how to do it, right? So formalize it. So figure out a recipe. Yeah. And remember, I think I by the way, guys, if you do this one, it will be a good practice for the assignment. It's the same similar thing, right? If you take a look, right? So it's this one. So stepwise refinement of an algorithm. So that's gives you a good practice. Yeah, in front of a hash. Yeah. And then make sure you put numbers though. Yeah, yeah, and then yeah, that's good. Yeah, I like that. How specific? Like, if I were to say, we need to first get like assemble or retrieve the ingredients, right? Yeah. Do I describe like the one, right? Well, do I like describe like open the fridge, grab plates? Yeah, maybe I don't think you don't need to go that detail. That's too much, right? So, for example, if you go really fine detail, and then that's also not that good because now you are, like, more verbose now, right? Yeah. So, if another person, someone totally new, can understand your language, that's a So those guys, all of you who know already how to code in Python, okay, this maybe is still boring, right? But we're gonna get to that point in with code, okay? So hang on to your horses, okay? So, um, so you actually write code, right? Okay. Well, that's fine. It's just written over there. That's fine too. Yeah. Yeah, that's fine. But I did not code still, but I only wanted English. In English, that means the algorithm only. So, so your right side shows you are printing the algorithm on right side. So I would say this is still kind of a value. So, but you have that in like this, right? So that's why I'm kind of discouraging to use already this because a lot of others don't know anything about it. And guys, remember, right? It requires steps, right? So, right, being elaborate, okay? So, see that? Right? So, if you again, this is again, if you want to see the rubric, okay, so you click on this three vertical three dots, and you can see the rubric, and you can see um, there are the way I grade you, right? So you have to both post your code as well as um, embed your solution, right? And also over here you will see that I think down below, right? Yeah, see that? So you require to write a major step and then the least substep. Let's say two, many steps under step two, 2.1, 2.2, something like that. So okay. So that require like having at least one major step with some substep, right? So think about that, right? In your smoothie, not just single major steps, right? One set of major steps. You come up with it, for example, right? So you say basically, like prepare fruits, right? So under that, you can say cut wood fruits and then you cut them. So step one wood, step two cut. So that's the preparation of fruits. You can imagine things. So be creative. Okay? Yes. It's fine if you work together. It's fine if you're not the same. That's fine as well. Just make sure you back together and do it. Yeah. Right. Okay. So this is what I'm going to do. Right. So you know important guys, do not think about programming like Python yet, okay? We haven't learned yet, right? All English. No, yeah, I think he wants a little bit more. That's fine. Oh, yeah. But you get a good grade. I think he wants a little bit more detail. Like he talks about is he said so not we took on more finer stuff, um, where he wants like basically you have one large stuff that's like now you need to um, prepare for you. And you would want to step one of preparing for this would be grab yeah, he wants to have a little bit more. And necessarily do that on every step. And guys, again, make sure you have at least one check that has other subsets, okay? Because, and if you take a look at the assignment this week, this will be really helpful you for you to successfully submit that one, okay? Let's have a copy. All right, guys. Yeah. So, guys, it's time. Okay, so 10 o'clock right now. So, if your food is done, just make sure you submit at home. Okay, and then basically, pretty much you have to do the same thing for the assignment. Okay, so and that's it. So, if you done with the module one, okay, we're gonna start doing the module two starting Tuesday. Okay, alright, guys. Have a nice weekend. Okay, so right? So if you want to, let's say, before you so English language is fine. But it's not more, I think more real than easier to understand. It's one of the reasons Python is really slow actually. So if you want speed and everything, then basically you can go C++. So, but we can still solve the problem in Python with overriding. And then these days we have technology that reads Python and spit out other languages for the other language. They don't have the artificial intelligence. You can solve the problem in Python, feed to that program, the program will depending on your choices, if you want to learn the whole coding and stuff like syntax area and also depending on the system program, more flexible and then just code. How you can just general coding and then also engineering stuff, like learning stuff. Then side the technical side, I think it's technical. But you can, Bridget, do they have a file system? I think, oh, she's saying you can answer it. Okay, you're welcome. Yeah, yeah. So shoot me an email and we take it from there. Because I have to start the other class now right now, right? So but if you can also come here around 12, then also I can talk longer. But if you send me an email, I can definitely answer your question. Or we can go attend the school office Friday and talk in detail. This time I'm going to send everyone an email. I have something in the morning, so I'm going to push it to the afternoon. So around 4 o'clock. Oh, okay, okay, okay. Okay. Yeah, yeah. We'll figure that out. So just email me and I will reply. Okay? Definitely. I love that. Okay. Oh, okay. Good. And you are in a good place, yeah. Okay. I can tell you met the right guy. Yeah. Okay. All right. See you Tuesday. Yep. Given is 004. You have my right? Okay. Okay. Yeah. Alright. So, yeah, so we have to buy it because chapter two, they don't give access to chapter two. How many guys? Good morning. Yeah, I'm going to talk about that.